So yes, got it. All right. So let me share that. Where's it gone? There we go. So share screen. There we go. I'm hoping that this worked. I'll get the chat open. If you can just pop a comment in the chat, maybe Claire, to make sure that it's working full screen. Yep. Awesome. That's great. All right. So yes, as I said before, I'm Elodie. So I'm a marine ecologist at Deakin, and obviously today I'm going to talk to you about spotted crab, but in the context of the biodiversity of the Great Southern Reef and all the mysteries that are surrounding this biodiversity, and especially spotted crabs. And I'm going to tell you about the research that we've done to investigate, to solve these mysteries, and also how you can help. So before I start, I wanted to acknowledge that this work is taking place on the land of the Wurundjeri, Wathaurong, and Bunurong people of the Kulin Nation. And I want to, I want to pay my respects to their elders, past and present and emerging. And I encourage you to put in the chat where you're coming from, what are the traditional owners on the land you're joining us from today. So, oh, sorry, I realize it's a Q&A, not a chat. Sorry, my bad. All right, so I wanted to start with a little bit of a story. So before I came in Melbourne about 9 years ago, I had the great pleasure of working in beautiful tropical Vietnam as a dive instructor. And I used to have Australian customers coming to the shop, and really people from all over Australia, and specifically some people from Melbourne as well, from around Port Phillip Bay. So I was always very excited when we had Australian customers to tell them that the next step of my journey was going to take me to Melbourne. And I was coming to start my PhD on seabird ecology. So I wasn't quite coming for diving, but regardless, very exciting. And I didn't quite expect the reactions that I got when I was telling people that I was coming to Melbourne. People were asking me, oh, you know, why Melbourne? They seemed surprised. And, you know, telling me, oh, there's no diving in Melbourne, there's nothing to see. So although I wasn't coming for diving per se, I was certainly hoping that I could have some good times in the water. So I started getting a bit worried, but fast forward a few months and weeks, I arrived in Melbourne. And after a few weeks, I got to dive and be presently surprised and relieved that the diving here indeed is great. And very colourful and some very unique species and environments to enjoy. So the point of the story is that when people are asked to, you know, think about a beautiful, productive, biodiverse marine system, I'm willing to bet that most people will think about the Great Barrier Reef and not so much sort of colder or more temperate environments like the Great Southern Reef. So yeah, that's a bit about me and where I'm coming from. And before I sort of jump in and tell you more about spotted crabs and biodiversity of the Great Southern Reef, I actually want to get to know you. So you can grab whatever device you want to use, either your cell phone or a tablet, or if you're on your computer, you can open another tab and go to www.menti.com. And there's this code that you can enter there, 75318727. And I'll switch my slide. I'll actually go to Mentimeter. So just bear with me for one tick. There we go, and I'll present that. So the first question I wanted to ask you is where do you live? So there's Greater Melbourne, somewhere else in Vic, another Australian state, or overseas. if you sort of spend your time between perhaps different locations, then maybe just enter where you spend most of your time, and I'll give it a little bit of time for you to answer these questions. And this is really for me to know where you're from and to tailor this presentation to what's most relevant to you, really. So I'll give it a minute. I can't remember how many people there were in this call, but maybe I'll give it another sort of 10 seconds or so. So again, if you're sort of working on that, take a device, go on menti.com, and you can enter the code at the top, and then sort of, answer the question. So I'll give it. Okay. So mostly at the moment, mostly Greater Melbourne, a few people that are, elsewhere in Victoria, and someone joining from another state. Welcome. I was a bit optimistic maybe with overseas, but you never know. All right. Oh, can't see the code, it's blocked. Sorry. So the codes, maybe Claire, I'll get you to pop it in the chat, but the code is 75318727. So hopefully that works. Yeah. Awesome. So another person from another state. Awesome. All right. So that's my first question to you. And one more from Greater Melbourne. Two more. All right, there we go. So I'll switch to the next slide. And I would like to know, for those of you who like to explore the marine environment, what do you do? So there's swimming, scuba diving, snorkeling. Perhaps you have a kayak or a stand-up paddleboard, or you do other boating activities, or maybe just, going to the beach or exploring the rock pools, or fishing, or maybe others. And with this question, you can actually answer, you should be able to answer multiple options there. So cool. Again, I'll leave a bit of time for people to answer the question, but I see you get the hang of it, so that's fantastic. So it'll be mostly, going to the beach, or people enjoying some time in the water, swimming, scuba diving or snorkeling, a few, kayaking, stand-up paddleboarding, a few fishing, and a few others. I'll give it another minute. Cool. Thanks for that. So I think the answers have settled here. So a bit of a spread there, but perhaps an equal sort of mix between sort of swimming, scuba diving and snorkeling, and beach going, and rock pool rambling. Awesome. All right. And then I've got one more question for you. So this is about, so spider crabs. Have you seen the spider crab aggregations? So the aggregations is when they get together in big numbers. Obviously, we'll talk about that a lot more. But I'd like to see if you've seen them in the media. So they've been, featured in documentaries like BBC Blue Planet 2, Magical Land of Oz, more recently the Southern Ocean Live. So perhaps some people have seen that. And if you've seen them both in the media and in real life, then you should be able to choose both options. It seems like at least the majority here would have seen them in the media. So that's great. This is obviously a phenomenon that gets a lot of attention. That's pretty spectacular, but I'm also glad to see that some of you have seen them in real life as well. And that's a real delight for people that can get in the water, but you don't even necessarily have to get in the water to see them. Sometimes they're visible from the surface. People that are kayaking or have stand-up paddle boards perhaps have seen them from the surface, or you can also see them sometimes from the piers under which they aggregate. So yeah, cool. It's good to know what crowd we're having here and what people might have seen or not. So thank you for playing along. and I will close my tea and I will go back to the presentation. So again, just give me a second. All right, so back to the presentations from current slide. All right, so I want to put this work in this presentation in the context, the broader context of what's called the Great Southern Reef. And the Great Southern Reef is this beautiful place that pretty much the southern coast of Australia that goes from New South Wales sort of all the way to Western Australia, and that includes Tassie. So it's a pretty massive area that's about 8,000 kilometres, and that's a series of interconnected reef systems that are dotted along that southern coast of Australia. And it's very important for biodiversity, but it's also extremely important for us humans in the sense that, you know, the Great Southern Reef support livelihoods, our economy, and also our well-being. So, you know, species and ecosystems along the Great Southern Reef are providing all sorts of services to us. And I guess back to what I was saying at the start, I guess a lot of people might not even have heard of that term of the Great Southern Reef or know it exists, despite the fact that for most of us, we've seen live in Greater Melbourne and some people in the rest of Victoria. It's really in our blue backyard. So the Great Southern Reef is home to amazing biodiversity. Oh, I've lost my clicker. There we go. So it's home to very unique and amazing biodiversity, from very sort of big, obvious, charismatic species like the great white sharks, one of the world's most endangered marine mammals, the Australian sea lions. So these are like the big obvious one perhaps, and then there's a whole range of species going from you know, this huge size to tiny. That on the first row, the second one is the pyjama squid, one of my favorite. It's it's actually related more to cuttlefish than it is to squids. Absolutely beautiful. We've got some sea slugs that I also really like. That's the second row, the one on the right hand side, the blue and yellow one, but they're much smaller creatures also on the Great Southern Reef. So you have some sea slugs that, you know, might be not even a few millimeters long, so kind of hidden, but just as interesting and rewarding to look up for. So this massive range of sizes, this massive range of colors, of adaptations. But the Great Southern Reef is also amazing because there's about 80% of the biodiversity that's found there that is found nowhere else in the world. So I'll let that sink in for a moment. About 80% of the biodiversity that we have on the Great Southern Reef is found nowhere else in the world. So that's even more so than if you compare it to places like, for example, the Great Barrier Reef. It's sort of, it will vary up and down depending on the group that you're looking at, either plant or animal. I know that I'm biased towards animals, especially here, but there's also incredibly important plants that are sustaining range of other plants and other animals as well. So yeah, very, very cool. And when it comes to Port Phillip Bay, there's also a very high proportion of species. Depends on where you read, where you get your numbers, about 70% that are found nowhere else in the world. So that's, you know, as special as our blue backyard is, and, you know, what we've got to really look after. And so not only the Great Southern Reef is home to that amazing biodiversity, it's also home to amazing natural spectacles that are found nowhere else in the world. So Claire in the chat there has put a link. It's a virtual tour that featured what's on the slide here. So this is the giant cuttlefish aggregation that takes place over in South Australia. in the upper Spencer Gulf. And over there in winter months, there's thousands and thousands of cuttlefish that come together to breed. And it's quite a delight for snorkelers and divers and swimmers that are, strong enough or brave enough to handle the cold water and jump in. But then it's very rewarding. You see all this mesmerizing displays that the cuttlefish are using in this sort of mating rituals, and you see like the big males fighting over females. It's really quite amazing. So if you do want to check that out and get more information, you can definitely check out the link that Claire put in the chat, and you'll have a lot more information and probably a good time, and it's a good activity to do as well with kids or your family. And of course, so the giant cuttlefish is one, and of course the spider crab get-togethers that we'll spend a lot more time talking about. So I'll go, yeah. And so, we have all this amazing biodiversity, species and spectacles, but unfortunately we have very limited knowledge of our marine environment. So marine environments offer sort of more constraints, they're harder to study, and they might not, as I said before, they might not be in the forefront of people's mind and sort of interests, so they get studied less. And that starts with so conservation status. So last year for Threatened Species Day, which is sometime in September, I can't remember the exact day, or I think maybe it might be the 7th this year, I was sort of preparing social media posts, and I wanted to feature threatened species that I would come across on my dives in Port Phillip Bay. I dive regularly and I come across all sorts of amazing things. And so I could, on top of my head, only really think of one, which is the short-haired seahorse. And I didn't want to like feature the big ones, like, the marine mammals or the maybe dolphins that people might already have heard of. I wanted to sort of pick one that perhaps people wouldn't really be aware of. And so, through this exercise, I actually had to dig quite deep, and I actually started checking out a bunch of species and looking at their conservation status. And you might just think, as like a gut feeling, well, isn't that a good thing that, it's so hard to, think of a threatened species? Well, it would be if it wasn't for the fact that actually the problem is that a lot of species in our marine environment actually haven't been assessed. So we simply don't know how well they might be going. And there's also species that have been assessed, but there's just not enough data for us to know their population trends. So are their populations increasing, decreasing, remaining stable? We just don't know. And the reason why that's such a concern is because as the broader environment, the marine environment is really under threat from human activities that are increasing and putting pressure on the marine environment. And that's even more true for this part of the world, because it's one of the areas that's actually warming, the water temperature is warming the fastest in the world. So this lack of knowledge is very concerning, given that, we could be losing species that we don't even know are in trouble, so to speak. And this lack of knowledge also extends to sort of basic ecology and biology for some species. And really, like spider crabs are a prime example of that. We have so many questions, and I'll get to that in a moment, and I'll tell you all about the mysteries that surround spider crabs. But some species questions such as how do they reproduce, how long they live, we just don't have answers to, which is pretty concerning. And then I've also put taxonomy on the slide here because there's a range of animal groups where we still actually have species to sort of discover and scientifically describe And one very good example of that, to me, it's more common in invertebrates. So that's your animals without a backbone. A good example of that is sea slugs. So you've got the second row, the one on the right, on the left, sorry, the other right, the one with the orange and black spots. Very, very pretty. So that's an example of a sea slug. So there's a citizen science program that happens actually a few times a year here in Victoria, but also in different parts of Australia. That's called the Sea Slug Census. And that's pretty much what it sounds like. So people just go out there and look for sea slugs and document sea slugs. So, as part of that, people can simply just take photos and send them through, or, people that are extra keen can actually try to identify them as well before sending the photos, see if they get it right. And on several occasions, I've done the sea slug census, and you come across, you have the photos, you're trying to identify your sea slug, and no matter how many books you look in, and I've got quite a few field guides and identifications guide, you just can't find it because it hasn't yet been scientifically described and doesn't have a name. So yeah, lots of things that we need to learn and understand about our marine environment. But now I'll get on to actual spider crabs and what we want to know about them and how we're going about that. So spider crabs form what we call aggregations. That is really a fancy word for get-togethers when they gather in very big numbers. And what I'm going to spend most of the time talking about today is it's a winter phenomenon, so it happens during the winter months, and the spider crabs come together to seek safety in numbers. So I'll actually move on. There's a video in a second, but again, to put that in the broader context. So this is work that's been done by Professor Gregory Jenkins at the University of Melbourne, and they've reviewed invertebrate, again, so your animals without a backbone, aggregations or get-togethers. So there's actually 9 in the world, and these are on the screen, and I've put a few dots here in Australia. I'll zoom in on Australia in a moment, so you'll see what it looks like, but pretty much these are the locations. So you've got the horseshoe crabs over in North America, the northern calamari in Taiwan. There's golden jellyfishes that gather in lakes in Indonesia, in Vietnam, and in Palau. And there's also 2 species of spider crabs that you see on the screen. They do form pods or piles, but not nearly as much and as impressive as the spider crabs that we have here on the Great Southern Reef. So the spider crabs that we have here, they're found nowhere else in the world, but there are other species of spider crabs that are found in other places. And so there's one species that form sort of little pods on the Atlantic coast of North America, and then there's one on the Atlantic coast of Spain. But then I'll show you for Australia. So we're actually pretty lucky that out of the 9 sort of invertebrate get-together that are they're called natural wonders, because people, they have high tourism value. So people are really keen to travel even long distances to come and see them because they happen nowhere else in the world. And yeah, usually people can see them in the water, so snorkelers or divers most of the time, but sometimes you can see them on land as well. So this is this is Australia. I've talked about the spider crabs, obviously, on the Great Southern Reef. I've also talked about the cuttlefish aggregations before, and there's 2 more in Australia. So over on the left-hand side, that little crab there, it's Christmas Island. So it's the Christmas Island red crab. This is actually a species that is terrestrial. They actually live in the rainforest, and they sort of migrate to the coast to spawn. And then there's another one, the ornate rock lobster, sorry, that's partly in Australia, so Torres Strait, and partly in Papua New Guinea. So again, four of them are in Australia out of the 9 that have been sort of identified worldwide. So that's pretty cool. And yeah, so most of them are related to mating or breeding, but perhaps not so much spider crabs, the spider crabs that we have here. And yeah, again, I'll talk to you about that a little bit later. But I want to start with, because there's a few of you that says that they haven't seen the spider crabs. Sorry, why? There it's playing. So I want to start with this video to sort of show you what it looks like. So again, in the winter time when the temperature is colder, you've got spider crabs coming in very big numbers. They haven't really been like standardized counts, so it's hard to say how many. Some will say tens of thousands, some will say hundreds of thousands. Again, it's hard to know because this data, there haven't been any records that have been kept of numbers and, you know, how they might sort of vary from year to year. But yeah, the spider crabs are about the size of an adult's hand. And yeah, so these ones are just sort of marching around, and then they're all on a mission. So they need to grow bigger. And in order to grow bigger, they can't do it just like you and me, because they have an armor of sort. They have an hard shell. So they're animals that are called arthropods. So these are your animals with jointed legs and this hard shell. So in order to grow bigger, what they have to do is to extract themselves from the shell. So it sort of cracks at the back, and then they sort of extract themselves out of it, and they expand their soft body. That's actually what you're seeing now on the screen. It's extracting itself from the shell, and it will take a few days for the new shell to harden. But this process, because it's so demanding energetically, it sort of leaves them stunned and uncoordinated on top of being soft. So that's the perfect recipe for disaster. If you're a crab and you're soft and you're uncoordinated, you won't be able to escape predators very easily. So at that time, really, the best place you can be is right in the middle of a pile, protected by other spider crabs. And here on the screen, you see one example of such predator. So this is a smooth stingray. I'll actually play the video again as I sort of keep talking about the aggregations. So stingrays aren't the only predators. There's others, like some small sharks, like Port Jackson sharks, for example. Some seals like to munch on them. Some seabirds even. So yeah, a wide range of sort of wildlife that is attracted to this this phenomenon and these spider crabs. This is taken in St. Leonard's this year. So that's on the Bellarine Peninsula, and that's actually a slightly unusual location. So historically, those spider crabs, at least in Port Phillip Bay, have gotten together on the Mornington Peninsula. So Rye Pier and Blairgowrie Piers are like prime spider crab viewing locations, or at least they have been in the past. But in the past couple of years, things have been a bit different. So last year, actually very few people got to see a spider crab aggregation. They probably were hanging out in deeper water, and only people who had access to a boat were lucky enough to see them. But most people probably would have missed them because they weren't at these piers. And again, this year also was quite unusual because there wasn't a lot of spider crab activity that was detected near the piers. There was a bit, but really the main show, so to speak, happened on the Bellarine Peninsula, where there was this aggregation that lasted a few weeks. And again, this footage was taken this year over there. Cool. So, all right. So again, so many questions. And this is, I'm still having trouble wrapping my head around this because, as I said, spider crabs are so iconic, right? They've been on BBC Blue Planet 2 and other documentaries, and they attract the love and attention of both the local community and tourists from far and wide. And yet, you know, we know so little about them. So one of the first questions we have is, where do they come from? So, and again, here I will refer more specifically to the spider crabs in Port Phillip Bay. So there's really two possibilities here. Either they live in the bay and they know, okay, it's showtime when the elements align, and they get together and they do their thing, they complete the molting process, or they could be traveling from further away from Bass Strait, potentially together and having to cross the heads. So the heads, that's the entrance of Port Phillip Bay, and ending up in the bay to complete their molting process, which would, I guess, tell us that there's something special about the bay. Like if they're willing to expend the energy to travel from such a distance, then we really sort of wondering why. But yeah, so these are the two possibilities. Where do they come from, and where do they go back to after the aggregations are over? Now, I've mostly talked about the winter time and this molting process, but spider crabs also do aggregate or gather at other times of year. And the community, the local community, is so passionate about spider crabs and understanding them better that they started logging on information on a Facebook page called Spider Crabs Melbourne. And the founder of this spider crab is actually here with us today. So PT, thank you for starting this. It was a great way to start sort of gathering this information when no scientific framework was in place to do so. And so on this page, you know, we got reports of spider crabs just popping up at pretty random sort of locations and places without any sort of pattern that we could recognize, and also for unknown reasons. So these aggregations that have been seen at other times seem to be short-lived. So it's, you know, it's hard to get information on them. There isn't really observations that indicate that at other times of year they're molting and that's why they're coming together. So we just really don't know. Then there's again, it seems like a basic question, but how many are there, right? And not only in the population and across their range. So the spider crabs are found really along the Great Southern Reef. So that's their range. They can be found anywhere there, but the aggregations are in sort of just limited places. But yeah, so how many are there on the Great Southern Reef, and how many are there during these winter aggregations, and does that vary through time? So that's an answer we don't have at the moment, but we'll be excited to find out. Then we're also wondering how important the aggregations are for the broader environment. So I've talked about predators before. So those massive smooth stingrays that are cruising around, or these cheeky seals that are coming to grab a soft crab. But we don't know how reliant these predators are on the spider crabs. And we talk about predators a lot because I guess these are the obvious ones and what we get, you know, amazed by for the people that experience the aggregation or see them on TV. But the spider crabs could also be food for a lot of other creatures in the environment, and particularly for scavengers. So any sort of animal that feeds on the bottom of, you know, remains of other animals. So when the spider crabs kind of extract themselves from their shells, there might be a little bit of meat sort of left behind in the shells. But some spider crabs, because this is a process that's expensive energetically. Some spider crabs might not make it and sort of die through the process and then become food to other animals. So one of the important questions we have is, what is the significance of the impact of this spider crab aggregations for the rest of the food chain? And then another question that we have is, what actually triggers these aggregations, these get-togethers? So there's some theories out there, but they're a bit fuzzy, and honestly, we just don't have good enough data to really answer them for sure. So one of them is that it's a phenomenon related to full moon. But then, and I've heard that over and over again, and people who have, sort of followed the story and had information about spider crabs would have heard that as well. But then sometimes you hear that the full moon is what sort of triggers them to start getting together and finding a suitable spot. And other people say full moon is what actually triggers the molting process, so when they extract themselves from their shells. So it's a bit unclear there, but the data that we have so far is a bit messy, as in, on the Facebook page that I mentioned, it's great that people have posted, for example, pictures and said this was the date and this is where I saw spider crabs, but it was always hard to pinpoint, okay, where is the start of that aggregation and where is the end, and what were the environmental conditions at that point, so we can sort of correlate it, more in a more robust way. And so moon phase could be one of the trigger, or it could also, and it could be a combination of factors, but temperature is also another one that I've heard a lot. I've heard people say, unless it drops, the water temperature drops below 13 degrees or 12 degrees, they're not going to molt. So could be related to temperature. Again, it's hard to say with the data that we have at the moment, but it's interesting to note that this year has been a bit unusual in terms of temperature. It's been colder faster in the bay. So perhaps this has influenced the fact that, spider crabs didn't quite do what we expected them to do, based on sort of historical encounters. So perhaps a factor there. And it could be other factors. So as we're building up data on where the spider crabs are found, we can then look at the environmental variables and sort of narrow down what the triggers could be. And then another question is, how do they choose where to go? So it seems like in the past, as I said, Blackberry Pier and Rye Piers were good locations for them. What is it something about the actual physical structures? But then why do they also aggregate at other locations? We don't really know. It's interesting that since we've started this project, people have reached out from South Australia and told us about aggregations in South Australia. And the reason why it's interesting is because everywhere you look, or if you listen to documentaries or you read articles, what's always mentioned is that the spider crabs get together in Port Phillip Bay and in some part of Tasmania, but I've never seen any other states mentioned. And we've had people reach out from 5 different locations in South Australia telling us about aggregations there. For me, it's like, wow, mind blown. Like, how is this information not sort of common knowledge? Has it not been logged before? So certainly we have a lot to find out. So that's why I'm so excited that with the team that I'm part of at the Centre for Integrative Ecology, and we've been lucky to secure funding from the Victorian government this year to start this work and actually start answering some of these questions. And to do that, we're using a mix of traditional science and citizen science. So I'll tell you about what we've done this season in the field, and I'll tell you about how you can help us sort of gather more data and solve some of these mysteries. So this was us in the field, kind of. The first thing that we did, we deployed time-lapse cameras. So there were cameras that were put at fixed places in the environment and sort of passively monitored what was going on for us. So we started with cameras at Rye Pier and Blairgowrie Pier for obvious reasons, because these were the sites where aggregations sort of have been seen before. But when the aggregation at St. Leonard's was detected and we got there to do field work, we moved some of these cameras there. So we also captured some footage from, or some images from St. Leonard's, which was very exciting because, yeah, the cameras didn't detect all that much at Rye and Blairgowrie. So there were some spider crabs, but always sort of isolated spider crabs and not so much sort of these spectacular aggregations. So that was the first sort of component of the research. And then we got wets and did surveys. So that was quite exciting. We used what was called diver operated stereo video. So that's pretty much like a tray with two cameras. And we mapped an aggregation and we did some transects. So that's to count spider crabs and estimate densities at different places in the aggregation. So we excited to analyze that footage. We haven't done that yet, but certainly will be our task for the next sort of few weeks and months. We also grabbed some spider crabs to determine the sex and the size. And again, that's back to where I was saying at the start, where even basic, biology data just isn't available on some of the marine species. So it seems odd to me that this data, there's just nothing in the literature, in the scientific literature. So if you look at, spider crab in aggregations to know if, are they mostly males? Are they mostly females? What kind of size are we talking about? That's information we just don't have. And then one question is, are males and females different sizes, or are they the same size? So we've actually measured and sexed quite a few, about 460 spider crabs. So that's very exciting data. And I'll be going to the museum pretty soon, next week, I think, and accessing more specimens and getting more data on spider crab size and sex. So that's another thing that happened. And then we did tagging spider crabs. So that's probably, I reckon that's one of the things that the community and perhaps some of you here is sort of more excited about, because that will allow us to track spider crabs and hopefully know where they go. So we put little devices on them, acoustic tag or trackers that emit pings. And when they come close to what we call a listening station that are sort of spread across the bay, then the spider crab gets detected and gets logged, and then we can understand their movement. So hopefully we will know whether they stayed in the bay after the aggregation or if they left. And if they left, we'll know, how long it took for them to disappear back to the depth and resume solitary lives like they have during the rest of the season. So I'll show you a few photos of what we've done. So the image on the left-hand side, that's Dan Iridakanu with his spider crab is in his hand. He's measuring a spider crab, and that's Darren Wong taking notes. The image on the right, we've got Dan monitoring a spider crab that we tagged. So you might notice, if you look carefully, the black thing that's on the back of the spider crab. So that's the tag that we're talking about. And these are lovely time-lapse cameras. So the one on the right, on the left, sorry, there's the one on the Blair group here, and the one, so that's attached to the actual structure. So that was nice and easy because the pylons were already there for us to attach cameras. And then the one on the right hand side, that's the cameras that we deployed at St. Leonard's. So we actually have to attach them to upside down milk crate that had weights on them so the cameras wouldn't go anywhere. And on this photo, you have a lovely array coming to check the whole thing out. So pretty good, some good photos for us to analyze later. And that's what a listening station looks like. So there's, I think if I'm not mistaken, about 44 across the bay, and there's a curtain across the head. That means if the spider crabs leave the bay, we have a pretty good chance of detecting them moving in and out, really, not just out. So that'd be exciting. And so, yeah, that's what we've done in the field this season. And now I'll move on to how you can help. So a lot of you are around the bay, or not too far away in Victoria. So people that actually are out there exploring the marine environment can help us by reporting spider crab sightings. So we've created this spider crab watch project on the iNaturalist platform. So iNaturalist is a citizen science platform, and it's not just used for spider crabs, it's used for just about anything, really. And the beauty of it is if you come across whatever plant or animal that you can't identify and you really want to know, then you can just take a photo of it, upload it on iNaturalist, and other people will jump in and help you identify what it is, which is really quite cool. So when enough people, I think it's 3 people, have identified that, yes, this is the species, the observation switches to what's called research grade. That means we're pretty confident that it's the right species. So I actually use that even sort of recreationally when I'm planning, for example, a dive trip. I will go and search a location and see what to expect, and should I take a macro lens or should I take a wide lens? Because, I can see what's there, what's been reported in the environment. So really, really cool app. And we have a spider crab watch project that relies on the platform. So in there, people so they have to create an account, but then can add observations. And so if you come across spider crabs, you can log that, and really logging sighting is quite quick. So all you need to provide is the date, the location, the time, and there's a few fields, a few questions to answer, and that's it. If you've got photos, amazing. We always love to see those, but you don't have to have photos to log sightings. And also, we really welcome all observations. So if you have spider crab information, photos from the past, then you can also upload them and help us sort of build that understanding of what's been going on throughout different years. So yeah, that's Spider Crab Watch on iNaturalist. So that's one way to help. But that means, you have to be around here somewhere or around the Great Southern Reef. But, before I go on to that, I got too excited. We also want people, we want people to report sort of normal spider crabs, either alone or in those big groups, in these aggregations. But we also want people to report when they come across molts. So I've talked about the molting process before, where they extract themselves from the shell and then the shell's left behind. If it's a fresh sort of molt, then it might look like the one on the right-hand side at the top, where you have like the full sort of body. So you have the back, you've got the belly, you've got the legs, so the full animal really. But if you lift it up, you can see that it's empty inside. And then, but when it's been in the marine environments for longer, sort of, moved around by waves and sort of eroded that way, then you might only get like the top part of the animal, like the carapace on the backside. And people, you know, have come across sometimes dozens or, you know, hundreds of these on the beach. And this is a very good sign that an aggregation has happened nearby. So for all of you who said they were going to the beach earlier, yeah, keep an eye out, because you could well be coming across these smolts on the beach as well. And yeah, so going back to the ways you can help, we're super excited to be launching a project on another citizen science platform called Zooniverse, and that will allow everyone at home to help us analyze the images that we collected with the time-lapse cameras. We collected a lot of images, about 66,000, so we certainly need the help. And so what this will entail, it's not live yet. The project is actually going through beta testing to make sure that it's all, you know, all nice and ready to go for everyone. And then people can log in and help us, you know, see, okay, are there any spider crabs on this image? And then you can identify them by, or label them by drawing a circle around it so that it will count spider crabs. And you can also help us identify other species that are on the images, so we know what kind of marine life is relying on these spider crabs or is around when the spider crabs are there. So that's our next project, next step. And this is going to be launched in a few weeks. So yeah, stay tuned for that one. And that brings me to the end. There's many people that I'd like to thank, starting with the Victorian government for providing funding for the research. There's a whole bunch of great people at Deakin that I'm working with, that I've been helping with design of the research and helping in the field as well, in sometimes not so nice condition. It's pretty cold at the moment, so big thank to them. We're also partnering with the Port Phillip Eco Centre and Victorian National Park Association. So big thank to them for helping design the citizen science aspects and helping with promotion. And there's a whole bunch of people in the community that have been legends and have been helping us spread the word, have logged in information and provided feedback. So heartfelt thank to them. And the last thing I wanted to say is reach out to me if you have any questions. If you want to chat spider crabs, I'm always available. That's my email address there. I'm on most social media platforms, so if you want to look me up, please do that. Send me a message on whatever platform you're using. And lastly, we also have a newsletter. So when the Zooniverse project is ready for everyone to analyze images, we will let you know. We will also communicate the results of the research as they come in. So if you want to scan this QR code, then you'll get to the right place to sign up for the newsletter. But I'll let Claire put if she hasn't done so yet, it's right there, all over it. So the link is in the chat as well. So yeah. Now I'm gonna stop talking and take any questions you might have. And I'll stop sharing. Are there any questions? Yes, a great question. How transferable is this work to other parts of the world? So not spider crab species. Yes, so that's a great question. So the methods that we're using can be can be applied for other species in the marine environment, whether they're spider crabs or not. So, for example, like what's called camera traps are pretty often used in the terrestrial environment to monitor the environment, see what kind of species are around. So it's not done so much in the marine environment because of the constraints, but certainly like the images that we've collected are showing us that this is a very valuable tool to document not spider crabs, sorry, just general marine life that's around. And in this case of spider crab, that's a nice bonus. But yeah, and so yeah, this kind of technique is really applicable to just any species or marine environment. And then, relying on citizen science is done more and more often. Hopefully, the sort of more powerful approach is to use citizen science in combination with traditional science as we're doing, and to, there's just not enough sort of marine ecologists out there to keep tab on everything that's happening in the marine environment. So having citizen scientists or community members on the lookout for, in this case, spider crabs, but whatever species you're monitoring really helps, knowing what's happening. And if you're relying on sightings from the community to go and survey a species, then that's even more crucial. Jack is asking if aggregation pics from several years ago are useful. Absolutely, absolutely. Please, if you have any pictures of previous years, upload them, because again, there's so little data out there that any sighting, any photo has the potential to bring us a lot more information that we already have. So yeah. Judy's asking a question about tagging spider crabs. So what we do is we have to wait for the spider crab's new shell to be hard. So there's no point in tagging a spider crab that's just about to go through this process, because obviously it was leave its shell and the tag behind in the process. And the way to tell the difference is the spider crabs that have just molted, they're like bright orange. Their carapace, their shells is all new and shiny. So it's usually really easy to tell. So we needed spider crabs that were in this condition, that had not a lot of, not any growth on their carapace. So sometimes the spider crabs have algae growing on them or other species. So when they're just molted, they're nice and smooth. And we just wait a few days for their shell to be hard. And then we know that the tag that we put on them will last for a while. And we're hoping perhaps even till next season. And when they come back next winter, we could catch them coming back in the bay. But again, so this is work that's never been done before. So this is kind of a pilot of sorts. So we have to wait and see what kind of results we get. But at least we should get them going out. And if we get them coming back next year, then it's a bonus. Salah's asking about size limit that determines when an aggregation is. That, again, very good question. There's just so little in the literature that there haven't really been any kind of definition, really. So it's a bit like a toddler, like how old is a toddler? I don't know how big is an aggregation. I guess there's two things there, though. There's, the sheer number of spider crabs, for example, if we're talking about spider crabs that are getting together, but there's also the kind of behavior they're displaying, I suppose. So, when they're forming these piles for protection, then, you know, it doesn't matter if there's like 100 or 1,000, it's, you know, it fulfills this, it is to fulfill this purpose of protection, really. So yeah, unfortunately can't sort of answer more accurately than that. Felicia is asking a tricky question about how long it will take to answer all the questions we had on the slide. This is a hard one because it's hard to predict what's going to happen year to year, because, you know, these aggregations can change locations. Sometimes they can be very short-lived. So, you know, if we have an aggregation that only lasts a few days and it takes us a few days to locate it, by the time we get there, it's kind of over, and that might be the only kind of chance we had to collect data in this season. So it's really hard to predict how much data we can collect in that one season. And, you know, some questions might be faster to answer than others, but some other questions might need 5-10 years of data. Is really hard to know. It's really hard to say because it depends on spider crab activity that can vary from year to year. The hope is that with future funding, hopefully we can extend this work to other areas, maybe Tasmania, maybe South Australia, if they have aggregations there, and sort of, you know, get more data in that one season, for example, by sampling more location if we can. So yeah, unfortunately, again, that's all I can say at the moment. I can't give you, oh, it's going to take 3 years or it's going to take 5. It's really hard to know. Yeah, so question about harvesting of the spider crabs. Again, this is incredibly hard to answer because we lack the baseline data. So as I said before, we don't have you know, population size. We don't really know where they come from. That makes it incredibly difficult to know. Well, for example, is it the same spider crabs that are coming back year after year? Are they completely different groups? There's just so many questions. So I guess this is, you know, part of what triggered this research, is that we can start gathering this basic baseline data. But unfortunately, again, that's not a question that's going to be answered next year because we're starting from scratch. So the more information we get through citizen science and through traditional science, and we can put the pieces of the puzzle together, the more we'll be able to answer this kind of question. But at the moment, the fact that in the past couple of years, they've done things that were slightly unusual or unexpected, we just can't link it to any human activity or disturbance or anything else that's been going on in the environment. And as I said, there's, you know, the temperature is fluctuating as well because of climate change. So, you know, what kind of impact that could have on spider crabs, we just don't know. So it's really difficult to tease all these different parameters and pressures apart. Jack's asking how long the just molted spider crabs are staying around. Again, it's one of these things, there's just not enough sort of basic data to really know. Sometimes there are aggregations that, you know, have been reported to only last a few days and sometimes a few weeks, and sometimes the spider crabs that have molted are sticking around. And it could be that sometimes they just leave straight away. Again, really hard to know unless we start getting more data. Yeah. Let me see. The normal diet for spider crabs. Again, I feel like a broken record when I say we don't know. Again, that's pretty basic information. I think from observations of what, you know, we've seen what people have filmed or photographs and have submitted, it seems like the eat just about anything that they can fit in their mouth that come in their path, on their path. They're scavengers, so they can also eat each other. So they, at that point in time, they can be cannibalistic. So the molting process is expensive energetically, which means that, you know, whatever they can get their hands on, they better eat, you know, and regain some strength about, you know, after that process that's really sort of expensive. Yeah. How and when they reproduce, again, basic question we don't really have the answer to. So this one is a very interesting one, because there's this sort of theory that, or it's not a theory, like most, if not all, decapods. So these are your animals with 10 legs, like spider crabs and other similar species, other crabs. They have to be soft in order to mate, for their genital opening to, the female genital opening to be available to the male. So that would imply then that the spider crabs would probably reproduce, you know, during the aggregations when they're soft. But it's interesting because if only a few people have reported what looks like mating behavior. So a male and female will be like abdomen to abdomen and sort of twist. And yeah, so, but that wasn't necessarily, that wasn't actually during the aggregation. So again, this is a big open question as to, yeah, how exactly they reproduce and when, and whether that's in aggregations, but we don't necessarily see it, perhaps because they're indoors piles, but there's limited sort of evidence or observations of mating at that time. Yeah. Let me see. Do the trackers log any other data, or are they just pinging location? Yeah, so just location at that time. Well, anyway, at that point in time, the trackers that we're using are just about location, but there are quite a few wave buoys in the bay that are recording a range of environmental conditions or parameters. So our hope is that we can correlate this data with the locations that we get. Yeah. But it's hard to get those small devices, because obviously with the size of spider crabs, you need small devices. So the smaller the device, the more likely it is that it will help you log a whole bunch of other parameters, but also it gets more expensive. So we'd have to have quite a lot more budget for that as well. Do spider crabs have an order? They pile up on each other, for example, younger specimens on the bottom. Again, don't know. We don't actually know their size or their age. Like this year is really the first year we started recording data like this, where we started measuring spider crabs and seeing, as I said before, if they were males and females. So really don't know. My gut feeling would that it probably be pretty random in terms of, you know, age or size. But I think what matters is, so potentially the ones that are at the center of the pile, they're the soft ones, and they're protected by spider crabs that have already molted, or and are hard, or they've not molted yet, and then they've sort of switched. I think that's more the way it works, rather than being sorted by sort of age or other factors like that. Can the composition of the carapace material tell us anything about their diet growth cycle? Yes, so that's something I'm hoping we could get budget for, and that's to analyze what's called stable isotopes. So that kind of analysis rely on the principle of you are what you eat. So you can sample in animals in general, you can sample different tissues that represent the diet at different times. So in terms of, so I was working on seabirds, for example, and we would sample their feathers on the body, and that has a turnaround of, you know, maybe like it's actually representing, sorry, the diet of when they synthesize the feather. And in the species that I was working on, they have what's called a catastrophic molt. So they lose all their feather at once and they regrow them all at once. So that if you sample these feathers, you kind of have the diet at that time. So it was probably a year ago for most species of penguins. If you sample blood though, because the turnaround is faster, then you might get a representation of the diet in the past few weeks. So with the spider crabs, if we translate that back, then if you sample the shell or the carapace, then you'd get an indication of the diet when they were growing the new shell. So during the aggregation, the previous year, potentially, if you sample during an aggregation, and if they haven't molted yet. But yeah, that's a very good question as well. Just going through, I'm not actually sure. I think I'm getting through most, I've gotten through most of the questions. Interested in footage of giant cuttlefish. Always for my pleasure, but not for research. But thank you for asking, please. And I think I've answered all the questions. Just wait a minute just to make sure there's no other questions. Thank you for your messages. I'm glad you enjoyed the talk. Thank you for tuning in late on the Tuesday night.